So in this video, we're taking a look at trajectory, bullet trajectory. And this is just like blood spatter analysis in that we're still going to use the right angle geometry concept. So the trajectory or the path of a bullet can actually be traced back to its origin as long as you have two reference points. Two reference points are required in order to define that trajectory and determine where the shooter was when that firearm was shot. So when we take a look at it, in this example, if someone was sitting in a car and they were shot, there are a couple of different points that we need to focus on. First is going to be, where's the horizon? Okay, as we're looking at the car into the past into the distance and looking at the horizon, we need to know where that is. We need to know where the bullet hole is in the car, where the bullet hole was in the glass as it passed through the window or the windshield, and then that will help us then determine where the individual was. So let's learn a little bit more about that. So these reference points, like I just explained, are bullet holes in objects or victims. So it could have been in the victim if the victim was still in the car. It could have been an entry point and an exit point on a victim. If someone was shot in the front of the head, where did the bullet come out in the rear of the head? It could be gunshot residue or spent cartridge casings, although they are less specific reference points. And then investigators can actually use better technology than they did in the video that we saw at the beginning of the unit, where they used the stringing and the straws. They can actually use lasers now to trace a straight line path to help determine the position of the shooter. So in determining this scenario, we're basically using that law of tangents again. So in this situation, we know that the building is 60 feet away, right? So that's the adjacent side. We also know the angle based upon the distances of the bullet to the window and the bullet to along the horizon. So because we know that angle, we can use the tangent of the angle equals, oh, I just can't remember all of a sudden, opposite over adjacent. So in order to find y, or the height of the shooter, we have to know that distance of the adjacent side of the triangle and the angle. So in this situation, the building, which is not in the image above, is 60 feet away. So we know that distance, that's a known distance. And we know, based upon that angle of trajectory, that the shooter was 11 feet above the bullet hole in the seat, which made him 4 feet above the ground. So this means that the height of the shooter was about 15 feet off the ground. So that would put the shooter on the second floor in that building. So what we're going to do in the next couple of days is we're going to be focusing on how do we determine some of those positionings using different scenarios and studying different angles of trajectory.